Hello? Hello? There we go. Check, check, mic check. Check, check, mic check. Okay. So now on to the mechanical part of this exercise. I need that string out of the way. Why did that drop? That's okay. Exposure on that is a little bit too intense, but okay, I'm gonna leave this here because I'm gonna need it soon. Now I need a case for this the case is basically I don't need access to the HDMI in the back necessarily. I might leave some slots open here for air access. We'll have to see. In any case, I could cut an alternative version with so I need a enclosure for this, and I am going to design that using acrylic, using these captive nut joints. This is essentially a screw that goes in through a hole on the bottom. Let me disassemble this so you can see what it looks like. So these are 90-degree joints with a nut and bolt, where essentially there is a T-shaped cutout on one side that captures a nut, and then a hole on this side where a bolt goes through, and then we'll screw in and through tension on this cross-shaped intersection will hold these together. This is how, or one of the ways that printer bots, these laser cut 3D printers, had their chassis assembled so that you could make a laser printer, a 3D printer out of primarily laser cut and off the shelf parts. For this 1/4-inch acrylic, the ideal size is really M3 M3 screws, which when centered should leave at least nothing hanging over the edge. Turns out getting large numbers of M3 screws from the hardware store, from Ace Hardware or Lowe's or Home Depot, is not easy. Yeah, like Ace Hardware, where the Orchard Supply used to be, does have some metric screws, but not a large number. And I'm going to need quite a lot. Each corner is going to need something like between 3 and 6 of these. And so I'm lots of corners in a rectangle or three-dimensional in a cube. So I'm going to need quite a lot of them. And so I ended up getting these pretty well-made stainless steel 6/32 3/4 inch screws, which are a little big. They did overhang a little bit. So if I put this guy back together, whoops.
Comrade, Orthodoxy has invaded the chat.
Go. Just yo. So they still might slide up. They're not fully affixed until they're tensioned. So these the screws back in there. Tension these down. All right. And so they hang off a little bit here. Not much I can do about that. Yeah, there's just not much I can do about that, and it's okay actually. The design does not require me to have everything completely contained. And so the way that this box is going to look, if I head over here, I can zoom in, is conveniently, let me get the top. Conveniently, the ADT-Link board comes with, they've got a step file that has a dimensional CAD drawing of the base components and all of the connectors. Plus, they have some versions that have some of these open source. Well, I don't know if they're open source, but they come with some models of graphics cards. So this is a 2080 graphics card model that they have already built into the assembly, which I then shaved off because the 3060 is shorter than the 2080. So this is shortened to the dimensions of the 3060. I had to get rid of a bunch of fins and stuff inside because there's huge amounts of complexity in these interior models that was really bogging things down. And so at the bottom here, if I hide now the graphics card, we've got the bottom of the acrylic box. There are these four. There's a slot cut out here because there's some screws and the bottom end. These tabs on the graphics card stick through. So the bottom of the ADT-Link isn't flush against the
has invaded the chat.
Isn't flush against the ground. And then there are these 4 feet. The 4 feet I will remove and remount outside the case. So the screw holes where the feet are these holes here. And so these 4 screws will affix the bottom of the acrylic case, of my homemade case, to the matching holes here on the ADT-Link to affix, whoops. And then I have a whole set of, I've got the front wall, and you'll see that I've got holes here for these captive joints. Same thing on the right, left, and the back. I haven't finished yet, so I need to use I have a script that does this that I didn't write. Someone else wrote. um, to finish the rest of the captive joints here on the back. And then there's going to be the top, which I've also not fully finished. I haven't put in the captive joints on the side here. Also, in this model, incomplete. So I'm still not ready to cut any of these components yet. That's why I used this test sample here, because I wanted to make sure that my clearances and everything for the screws and everything were right. But I'm a ways away from getting from actually printing any of these parts. I wanted to validate that I had my settings right, particularly my kerf settings, so that things wouldn't be too snug or too loose. But then then I have to put in on the front wall possibly a slot to access the HDMI ports and for cooling, and also on this front side is where I will need to put in a mount for this guy here. This is the PCIe, the NVMe to Thunderbolt adapter. This guy's critical. And this was previously in this plastic box I think I had before, right? And it was held in by tape. And what I'm going to do is there are four screw holes here that I guess must be that are really intended for mounting. But those four screw holes here, right, are actually two they are too small for any reasonable gear that I have. So what instead I'm going to use there are three bigger holes that are really intended for the heatsink to hold onto this. The heatsink for if you had an NVMe drive, there's a heatsink thing that can go onto this. I don't have an NVMe drive, so I'm going to use these three holes instead to mount this against the acrylic wall. So I'm going to need to cut three holes, and then I'll hold this in. Now the problem is, it is this side here that has nothing, right? Or it looks like it has nothing.
Comrade W_general has invaded the chat.
This part here
W_general said,
yo. So this part here, which looks like is nothing, is actually where the NVMe cable from the ADT-Link is going to go into. So it is this side with the EMF shield and all of the components sticking out, including, I don't know why, right? This 2R2, right? This would be an inductor. So there's a hole cut out in the EMF shield for the inductor. Not electrical engineer. Not sure why that. Anyway, whatever. And so this end here is going to need to go in against, is going to go against the wall, but it's going to need standoffs. I'm going to need 3 standoffs here. And so that's what I'm going to start with right now is, before I get to cutting onto this front wall, the 3 holes. I'm going to need 3 holes that I measure exactly to match this. Before I do that, I want to create the standoffs. Let me save this. Let me create a new design. And I'll call this one. The hell is this thing called? Wavelink. The Wavelink NVMe standoffs. As you may notice with a multi-camera setup, my plan here is to laser cut the standoffs. So I will not have control over the standoff height. The standoff height will be 3/4 of an inch, which is a little bit more than I need. Now this inductor does sit pretty high um, off the board, but not a full 1/4 inch off the board, but more than 1/8 of an inch. So it's gonna stand out some amount, right? And that's fine. And then once I have that, I can then make sure that the hole that I cut, the slot that I put in the top, or to let the Thunderbolt connector through the top case will be positioned properly. So let's measure. I just need mainly is the inner diameter that I need, and then the maximum outer diameter, approximately. Use the measurement. The caliper is 3 point, I'll round down because I can be a little bit smaller. 3.3 millimeters. Let me create. No, not a component. Yeah. On this plane. And circle 3.3 millimeters. Okay, and then I'm going to need the outer diameter. I don't really want it to extend and obscure anything. I'll select that at maybe at the thinnest part of the board. That is 1.9 millimeters. We'll say that's 2 millimeters. I'll make that outer diameter 2 millimeters, but it's 5.3 millimeters. Whoops. .3 millimeters. All right, it'll be interesting to see whether I can cut such a thin piece without some heat deformation problems. Now I'll take this, I'll extrude this out. The extrusion is just for 3D purposes. Obviously, since I'm laser cutting it, the extrude distance does not actually matter. And this will be 5.6 millimeters. So this is the standoff. Now let me generate an SVG out of this guy. The cam way. So I'll need to create a setup, machine for this setup is the Glowforge, and the orientation, we'll select the X and Y. Okay, that's correct. Whoa. No, what? Oh, messed this up. Select the Z-axis plane, no. Select Y and X and Y axes. No. Oh, I have no, I can't do it this way. I have no straight lines. I do select z-axis plane and x-axis. A bit. Is this allowed? This is the X and Y that I want. Okay, that worked. So create the setup, right? That defines the machine. And then I need to create the 2D profile. The tool is going to be Glowforge. And then I want to cut these in separate operations. So no lead in, no lead out, contour selection. I'll do one operation for the internal and then another one for the external. Okay. That should do it. Save this. Do a post process to generate the SVG. So what this will do is the SVG post processor for the Glowforge will automatically, for each separate operation in the setup, make the lines in the SVG a different color. And those different colors will allow me, when I go to the Glowforge software, to select the order of operations. Everything that's the same color is considered a single cut, and Glowforge will decide on its own how to do that cut. But if I want to do any manual ordering, then through colors, I can then group the cuts and control that manually. And in particular, I want the inside to be done before the outside. If the outside is done first, that'll fall through, it'll shift, and then the inside will be inaccurate. So I want the inside to be cut first, and then the outside to be cut, and that outside cut will cut it away from the material. So I'll call these NVE standoff into my pictures folder. All right, post this. Take a look. NVMe standoff. Hard to see here, but yeah, two lines that are two different colors. All right, now let us go over to the, oh, first, let me go turn on the Glowforge. The Glowforge is Wi-Fi connected through their cloud generation software, so it's easier for me to set this up with the Glowforge turned on. Let's head over here. Go to my Glowforge. HAW643. So create new design, upload from file, got the NVMe standoff. There it is. Okay, so here's the scrap that I've been cutting test pieces from. So, where? Somewhere. Over here. Like material, I can't read the QR code. It's fine. I know what it is. What is this? That's the inside, and that's the outside. Inside, outside, right? So I want the inside cut first, and then the outside. We'll see if a piece like this can actually be laser cut. Let me check that I have the vent set up properly. Let me hit print here. And then I'll go check if the vent is set up properly, because I don't want the acrylic fumes coming into my room. And no, the vent's not quite set up properly. All right. Now it is. There we go. The button is glowing. You know, I should turn down the intensity of the Nvidia broadcast. Noise cancellation. So I'm betting that you're hearing like weird distortion when the fans and stuff on this came up. So now let me get this piece out. Need a little tool to push that standoff out. There we go. Not terrible. The cut was pretty fast, so it's not super terribly warped. But let's see. Put this screw in. Standoff is... Actually, I'm not worried about the standoff being too big because the screw isn't going to come in from this direction. The wall will be here. The standoff will be here. This will come in through the acrylic, through the standoff, and then be bolted in here. Okay, so that works. This will work with M3 and work with... It will not quite work with the 6/32, which is fine. I have I have a set of M3s, not enough like the box of 100 that I can get from the hardware store here. But I have a set of different length M3s, and I only need 3 of them. So this will have to be M3. Got the standoffs. Okay, good. So let me go put this back into the laser cutter. Let me double check. What am I? Here. Oh no, W General. Where did you go? All right. Now I gotta place some more of these guys. I need 2 more. Actually, reduce the heat. I would like the then paste. Why can I not do this? Why are these forced to be a group? There we go. Paste this new step. So why do I want to do this? I want to cut the 2 inside ones first. All right, so inside, inside, outside, outside. Minimize the amount of potential, to give it more time to cool down. Let me also select, whoa.
Hytron C has invaded the chat.
Select.
Hytron C said, this for the new enclosure for the PSU and headers.
Yes, or it's just the enclosure. I'm not going to put the PSU. The PSU is this chonky guy here. I'm not going to put the PSU inside. So it's just for the board and mainly for the cabling, because this is sensitive high-speed cabling. That is, it seems reasonably robust, but it's carrying PCIe X4, so I'm I want to make sure that it's well contained. Standoffs.
Said, yeah, don't want to accidentally squish it while otargying.
Yes. So these are the, I'm making now standoffs so that I can mount, this is the NVMe thing. I have to mount this against one of the walls. And so it's got the circuitry along the back, the side that's going to need to face the wall. So I need standoffs so I don't directly crush all of the inductors and magic in here. All right, print. Calculating precision movement. Taking a while. Hey, the button is glowing, meaning there's a print ready to go. Fan spinning up. Good thing is that these really small cuts don't generate much in the way of fumes. Oh no! Oh, phew. I thought it might have dropped through. For big guys, I don't bother taking this back to my workbench because I can just push them through. But for these little guys, I want to bring them back here so that I can push them through and not worry about having them drop into the mesh tray.
The camera transition.
This is the same as the ones we use for the regular show.
C said, yeah, I know.
Let's see. All right. Oh, I guess in the regular show we don't have this many cameras, right? Because I got a lot of views here.
Said, they still look great.
Yes, I've got 4 views here. I guess we have had 4 views on the show before, but we don't make very creative use of all those views, because not all the people are in the same place. It's hard to coordinate. All right, what's going on? So I've got one standoff here. I've got one guy here. All right. A little trouble getting the inside piece out here. And push through. There we go. Okay, and let me get my fingers. Paper off these 2 sides. This might be the most exciting part for today, because I am not sure that I will get to cutting any of the big pieces. So for standoffs like this, we have some exciting cycle times where I can design and then print or cut in a reasonable amount of time. Let me get the junk away. Here are my 3 standoffs. Hope I don't lose them. Throw the trash away. And put the scrap piece away. Okay, so the standoffs are ready. And let me measure them again because these guys are all now a little heat warped. 6.1 millimeters. Okay. 6.0. 6.0. That's way thicker than what I measured. Oh yeah, they're all longer because the bigger block of stock that doesn't soak up so much heat is 5.7 millimeters. So they elongated in the z-axis by like 0.4 millimeters, by almost half. These are almost half a millimeter thicker than the stock they came from.
Said, expiring in 10 days.
Oh yeah, why is this? Why is it expiring in 10 days?
Hytrons C said, Autodesk.
Yeah, but I have this connected to, this is the educational edition tied to my NetID. Should not. Oh, unless it's a local cache. It was 12 days when I launched this 2 days ago.
Is it hardware change?
No, this is supposed to be app streaming, so it just wants to phone home. Let me launch it again and see if it goes back to 12 days. I know that it will only last a certain number of days before wanting to phone home. Oh, now it's 9 days. Well, I should be done in 9 days. I don't actually know why it's counting down. I don't know why it's counting down. It never used to count down. Well, it doesn't really matter. If I have to downgrade to the hobbyist version, that's fine. The main thing the hobbyist version cannot do is it cannot export step files, which I don't really need to do. Okay, back to the base project. Yeah, so conveniently, the manufacturer of the eGPU, the PCI to NVMe board thing that I have this mounted on, has a CAD file, a step file on their website with a bunch of examples of both dimensional models of both the hardware and also examples of how different cards fit into it. So I took the one with the RTX 2080 in it, and then I shaved off, you'll see, the back end of the 2080, because Pure has 3060. The 3060 is actually shorter. And all the other dimensions are relatively correct. And so then I could line up the holes that I'm going to use to attach this to and all of that. and make sure that the case is tall enough, but not too bulky. What do I want to do first? Yes. I guess I want to model the mounting holes for the standoffs. And I'll call these standoffs 6 millimeters. The distance of the standoffs actually won't matter for this operation. All I need is 3 holes. They will matter for the top because I'm going to have to cut a slot open here to access the Thunderbolt port. But one step at a time. What I'll probably model here is both 3 holes and a slot for the ports to peek through.
Said, "Oh wow, you have a GeForce model."
Yeah, the Chinese website where for the ADT-Link has a package of CAD files, and the CAD files include both the base and the base with various stuff plugged into it. Now this model isn't exactly the same. The 3060, obviously, the 3060's ports are not in the same order.
Itron C said, "Oh, I see."
But I guess because it makes sense, because a lot of these devices that are more meant for B2B use, they'll come with step files, because since there's no enclosure for this, anybody who buys one of these in bulk, if I'm going to buy like 1,000 of these, I'd be presumed to need to integrate that into some other project. And so like
ITSDATGAI has invaded the chat.
So like on like at McMaster, almost every item in McMaster Car's library has step files associated with them, so you can exactly model the parts in an assembly. 3D printer guys have been making use of the McMaster library for years by taking those step files and then using the step files to print a plastic version of a given part. So for people who are into like printing their own screws and weird stuff.
Said, "I like how TPS just spells his name instead of trying to pronouncing it lol."
Yes. Well, I mean that's how you should hear this.
Arnie C. Lover Club said, "What is my name?"
Although interestingly, the way that this TTS, which I think is Google TTS, breaks down any Clover Club, is the same way Siri does it, like in my car. All right. Yes, the port order is a little bit different. This is like what? DisplayPort, HDMI, another DisplayPort. Whereas in the 3060, HDMI is on the bottom, and then there's 3 DisplayPorts. But I think left to right. Oh, and then on the 3060, the ports are shifted to the left a little because the ports on the 3060 are obstructed by this second pillar. So in order to access the ports, I will have to remove the left pillar. I can't have it installed. Which is fine. The right pillar is strong enough. And so long as it's in the orientation it should be. And it has to be in this orientation because I'm only screwed on from the bottom. I'm not clear that this apparatus is strong enough to be held to hang off the side like it would be in a tower case anyway. So, okay. Start with the standoffs. So let's put in the, take the 2080 out. Let's put in the front wall and the left wall. No, okay, I don't want to do that yet because then it'll get my sketches all mixed up. Mm, to do. Okay, so here's the dilemma. This is more of a design issue. The order in which I make things makes a difference to the structure of the project. So see in this timeline, here's before I put the cutouts in, and these are all flat. And these sketches were created earlier in time, therefore they're higher up in this folder where the sketches are. And then fast forward here, the captive nut cutouts are all script generated, and they have sketches for each of them. If I then create more sketches after this, let's say because I want to reference the location of these cutouts, then they will pop up down here. You can't reorder these because these are all the ordering of the sketches here are going to reflect the ordering in which these are created here. So the question is, do I want to have my features essentially split up and have some of them before this massive auto-generated sketches and then some after? Or can I just remember where these are going to be and do the whole thing in the before? Okay. I think I'm going to make another group of these after, just so that I don't make any mistakes, because I am not an expert. However, I do not want them interspersed. I don't want some of my sketches and then auto-generated sketches and some more of my sketches and then some more auto-generated sketches. So I'm going to finish all of the auto-generation that I have not yet done. So you'll see that I have not yet finished all of the captive hardware I need for the top and for the back. So let me finish that first. Then I'll get into the here are the top cutouts. Hello. Oh, I hid them all. And okay, I actually have all the holes I need defined already, all the points I need defined already. So let me turn this back on. Yo, why can't I select them? Why can't I see them? Yo, where are those points? I thought I projected them through. Yeah. Bottom, all the walls. They're here. The sketch points are here. Oh, okay, fine. The sketch points are here. I must have had the sketches disabled or something. So let me select the sketch points. Turn on the top, the left, and the right. Yep, that's where I'm going to drill through. And then tools, add-ins. Add in the script. Fusion captive joint add-in. Create captive joint. See if this works. It's going to work all at once. I'm going to have to do them one at a time. There's some weirdness in the way that this is computed and some of the boundary conditions here, where sometimes I need to do a cut operation and sometimes I need to do an intersect operation. It's got to be the case that there's some computation done in this Python script that lands like right on an object boundary or something, because each of these is a separate body. So it's doing some fairly interesting kind of directional detection to try to find all of the bodies that intersect this shape and then cutting them through. And looks like cut worked there. Magic. This would be a pain in the ass to do by hand. I spent some time yesterday trying to understand how this Python script works, because it doesn't work 100%. Because doing all of this modeling without the Python script would be extremely onerous. All right, that's good. And then also like these numbers here, which you can't see. The parameters on the right-hand side here, these by default are set for an M3, and I had to modify the code to change the defaults to be for this 630 seconds, for these 630-second screws that I have.
Hytron C said, ha ha. Hytron C said, metric problems.
Oh yeah, I spent an hour at Ace Hardware yesterday trying to find enough M3s, and they just didn't have enough. And so I had to go with Imperial screws instead. Because and I went and looked online to see if I went to Home Depot I could buy them, but Home Depot has even a smaller stock of metric. And so if I just need like one or two or three, I've always gone to Ace Hardware where the Osh used to be, and I can get what I need. But I need like 50 of these. Or okay, not 50, right? 1, 2, 3, 4, 8, 9, 10, 11, 13, right?
Home Depot's screw section is really hit or miss.
Yeah. I need like 30 or 40 of these, and
Hytron C.
Yeah, they didn't have enough.
Like people toss stuff into the wrong drawers.
Oh yeah, Ace actually, I don't have too much of a problem with that. People don't do that.
Said, can't buy online.
I can buy some online. I bought an M3 kit online, but I really wanted to get this test done yesterday. And so I really needed to buy them at retail. For the standoff, I got a kit of M3s from Amazon of different lengths. So it doesn't have a huge number of each screw, but it has a variety of lengths. And so that's convenient because I only need 3, but I'm not exactly sure how long I'm going to need. Okay.
C said, do you need heatsink for SSD?
No, because there's no SSD. This is just the PCIe adapter thing.
Said, the SSD to PCIe card I bought came with heatsinks.
Oh, yes. Yeah, so this came with a heatsink too, and I'm using the heatsink hole to mount this because the actual four holes that look like they're designed for mounting, they're too small. I would need something like an M2 screw to go in, and I'm not sure that they make M2 screws long enough. Yeah, because below M3, things start getting a little weird. Like the Kaus blades, the screws I have for the small number of screwed in parts there are M1.5 screws. At first, I didn't even know they made them that small. There were these mounting holes in the LCDs. I was like, what size are these? And they're M1.5. And those only come in a very, very limited set of lengths. I mean, I presume that at M1.5, if the screw were too long, you could just like snap it in half. All right, so we've got that generated. Now we need to generate the three matching holes to connect the back to the sides. All right, so let me hide the top. I want the top, I want the back and the front cutouts. Project these already? Let me see. I did some work on this yesterday. I can't remember how much work I did. No, it looks like I did not project these already. Let me project these 6 points onto the surface. Six points, run the script. I also took quite some time yesterday to simplify that model of the 2080 because this command here does some magic where it looks for intersecting objects, and the presence of the 3080 model like made this crawl. It was super slow. Oh no, index 0 is out of range. Oh, okay, so, all right. This is the boundary condition error where for some reason one of these cuts, when the scripted action runs, ends up cutting the whole object away. All right, let's do the left side first, and then I'll figure out the right side. There must be some check that the script is not doing. But same thing. Yeah, so these are supposed to be cuts, but for some reason now, instead of a cut, it created a solid representation of the cutout and then cut the rest of it. Okay, so I know that's the bad one. So let me do these two. Let me do this one. That's fine. And then let me fix it by going into this generated operation, and then I change it from a cut to intersect. Now, I have no idea why this works. changing the operation from a cut to an intersect. Um, um, Someone who understands the API, this would probably be obvious that there's some kind of check that the script doesn't do, or something. I'm not sure. Yeah. I forgot which one was the bad one. The top one is the bad one. So let me do these two. But this problem I didn't feel was worth fixing. The amount of research I'd need to do to understand the Fusion 360 API is just too great. This workaround is sufficient. Here, change this to an intersect. Okay, let's see if I have all of these done now. Sketches. So each face should be held on all four sides. And I'm not missing any. Notably, what I don't have modeled in is any handles. I'm a little nervous about how strong this box will be. Acrylic is very rigid, but brittle. It's not a resilient plastic. You normally would use acrylic for stationary and not mobile projects. Arguably, but I can only cut two materials, acrylic and wood. Wood, I have to worry about the grain dimensions and it being strong in one direction and weak in the other. And I'm not confident I'm being able to model that. So whether I made acrylic or used acrylic or wood, I'm not sure where the stress points are in a design like this, because notice that the corners are not actually directly joined the way that this works. I don't think it makes a difference because the tension here is going to put tension across the whole edge. Everything here is going to be held in or rather, it's not tension, it's compression, right? Because it's pushing it. All of these edges are going to be held in compression. So I think then so long as these edges are not like really off, that they should be evenly loaded. But I just don't know. I don't know where the stress risers are. And so I don't know what the right place to design handles is, where you wouldn't be making I wouldn't be making a mistake and focusing stress in some place that I shouldn't be. So for now, to prevent accidents, no handles. So I'll always grab this thing like around it. But it is going to be a bit awkward to carry. This is only designed to only good enough to offer protection to the innards. It is not optimized for transportation. I honestly think it may be overkill. That this actually just may be compared to how heavy the innards are, that it's probably overkill strength overall. But given that 3060s are rare, and this isn't even my 3060, I might as well be conservative and not make a case design that could be prone to accidents. Don't think I'm missing anything here. Okay, so now I'll move on. I put these sketches into a folder or something instead of having them hang out here. It's going to be really annoying for me to have to jump up and down. Selection, set, edit, sketch, remove appearance, override. Come on. I guess there's, yo, I guess there's, no, I can't move them. I could create a new component, but I can't move these to a completely separate component. Right, because components are for bodies. Oh, and I moving a body into a subcomponent won't make any difference. Fine. It looks like there's nothing I can do. Can I take these groups and further group them? The answer is no, I cannot. All right. The downsides of scripted object generation is lots of junk. All right, I'm just gonna have to live with it. I'm certainly not going to try to remodel this on my own to turn this into one sketch. That is just too much work. All right, let's take a look at the front wall now. Front, bottom. I'll get rid of the left and right. I'll turn on 3080, the 2080 rather. Right. Now I'll create a sketch here. Let's see. First thing I want to do is these 3 mounting holes. Are about 20 millimeters apart. They're a little bit less than 20 millimeters apart. That may be cut error. I mean, this part was designed in China, so I would expect that it would be, wherever possible, they would use integral. Yeah, I think it's 20 millimeters. Anything else is just inaccuracies in routing. So there are 2. Point here. Here. Let's dimension those points. Points are 20 millimeters apart. Then I need a construction line. Okay, let me do this differently. Get rid of those two. 2 points make a line. So let me make a line that has a horizontal constraint that is 20 millimeters wide. Oh no, why was that? Why did that say that it was like some e to the minus 26 degrees? 0 degrees. 20 millimeters. Okay. I want this to be a construction line. I want another line at the midpoint here going down some amount. What amount? All right, how do I measure this? I want to find a way to measure this directly and not have to use trigonometry. I think maybe I eyeball it. Eyeball it. Is it 12 millimeters? No, it's not. It's more than 12 millimeters. Is it 13 millimeters? Looks about right. I think it's 13 millimeters. Where's the heat sink? This is the heat sink. This is the heat sink. This doesn't offer me any clues on any better way to. Not 13, it's 103 millimeters. Three millimeters, is that right? Seems to be. 103 millimeters. Hope that's close enough. For this, I want 90 degrees. One. What? Hmm. 103 millimeters is quite a lot. especially given how long these things are sticking up. Should have gotten shorter screws. But 103. Left and the right wall. Getting awfully close to that wall. Okay, this is a problem. It's because these screws stick up so high that they're obstructing where I can place. Whoa, where's the center rotation? They're obstructing where I can place these holes. Ah, they're obstructing where I can place these holes. I think I may be okay. I think because the base ends pretty much here. So this hole can pretty much go down as far as, but I didn't really want this thing to be so far down. I really want this to be as high as possible. It's got to be as high as possible. Otherwise, I can't access the Thunderbolt port. The Thunderbolt port is going to be at this level. I can't have to use pliers to plug in. That makes no sense. I need this like up here. I'm gonna have to change the top sketch. I'm gonna have to change this so that this top wall here is held in by only one captive nut instead of two, so it's not symmetric to the bottom. Can't think of any other way to do this. So this is basically, I need front and top. This one and this one. So I'm gonna have to delete these. Delete both the group and its contents. Is something terrible going to happen? Come on, no conflicts. What happened? Why did nothing happen? Oh, because I did the wrong ones. Those are the back ones and not the front ones. These are the back ones. These are the front ones. All right. Let me rewind back here. So what I want back here, okay. Project as a construction, project the front wall, and then create a construction line from midpoint to midpoint. And then along that construction line, create a point at the midpoint. Okay. Top wall back on. The one that I want. Now add in create captive joint. Okay. Now fast forward. Front. Now there's only one here. That's okay. I like to hear that I'm still seeing these points. This sketch here. The sketch is front panel. Now I have space. And how big do I want those holes? I want them M3 sized. Means about 3 millimeters. Yeah, 3 millimeters. pretty much want this as high as I am comfortable going. Dimension from here to, no, not to the center line, to the circumference. Okay, I can't do that. I cannot do a do not have a okay. Create two construction lines with the tangent and the horizontal vertical, and then set the distance for those. I guess I can. I don't know if that's the best way.
Another TTV viewer has invaded the chat.
Yes, because I can create a construction rectangle here. All right, and then create the tangent. Okay, that's okay. Create the tangent constraint. Here, right? And then I will dimension against that tangent. Let's call that 2 millimeters. Give this 2 millimeters. All right, that should be enough space for the cutouts. Code 3, 2 is 5 millimeters. Oh, I need a little bit more. Oh, yeah, I need enough space that the standoffs don't get blocked. So the standoff is about 5.1 millimeters in diameter. Really, I want to give it that is enough space, right? Three across here, 4, 5, 6, 7. So there is enough space here. There's enough space here for the standoff. Radially, 5.1, right? Radially is 2 meters, right? Divided by 2. It only sticks out by 1 point something millimeters. little bit more space here. This doesn't need to hug so far. I can put it 5 millimeters in, 2 millimeters from the top. Fine, 2.5 millimeters from the top. Oh, okay, and then I need sketch a cutout for the ports. Wish I didn't have to scroll by all these junk sketches to get back to the bodies. At the front wall, and let's see. Cut out same height as this about, but I want to go over, and since I know that the bar obscures the connection, and some of these cables can have chunky may have pretty chunky may have some pretty chunky housings. I want to kind of go all the way up until here. Here to here, right? Okay, so that's from up here, maybe. Okay, so let's get some projected references. Oh, sorry. Can't project that because I made it unselectable. Now, let me project the top of that. And the bottom of also project this and this. That should give me my references. Okay. Make this unselectable again. Okay, now I have my rectangle. Damn it. Do you see what I see? The top slot may not be fully accessible because I don't want to have the distance between this and here too thin. Yeah, that top display port may be inaccessible. So This is actually, I need it to be a cut line. First corner is there. Down here. I'll have a dimension here. Let's give it an extra 8 millimeters of clearance, which should be plenty off the bottom. And over constrained. Why is that over constrained? What? Fine, 1 millimeter. I don't understand. Why can't I make that collinear? It doesn't really matter, but a little weird. All right, then I need some fillets. Ah. Yeah, 5 millimeter fillets are fine. So got the holes. Got a cutout for the ports. I think I'm good enough now to print out the bottom and the front to measure this. I guess that would be the prudent thing to do. I mean, it's not like I'm gonna... And the question here is whether I should... Oh my God. Okay. Where is this? It is on the outside. So why can I not select this feature? Hell. Extrude. Oh, because I wasn't visible. Okay. 1, 2, 3, 4 objects. Operation. Cut. To object. God. Turn off the left and the right walls. To object is the back face. There we go. Oof. Got the mount here, slot. Here. And I'm going to need.
Simaximsum has invaded the chat.
And then I'm going to need, right, because the fan, what's modeled as front in this model is actually what you would normally consider the back of the card, except I imagine that I want all my, because this is a portable rig, for ease of access, I would want all my ports to be on the same side. So the way that this would be set up is this surface here, this is the front, right, where all the ports are. The Thunderbolt is going to stick out the top. So this guy is going to be floating here, and then Thunderbolt is here. So Thunderbolt goes in from the top because I can't do this any other way. There's nothing. Could I do this like this? Have it be sideways out like this out the back? Run into the same problem. The height wouldn't matter as much. You do that instead of mounting here on the back with the Thunderbolt on the top, mount it on the side. Maybe over here. Uh, I would still say no. Because fundamentally, the Thunderbolt cable is going to a computer. And if these are in use, which they won't always be, like when we use them at Fuse, the HDMI and the display ports, they're fundamentally going to monitor. So the Thunderbolt port and the monitor ports will be going in different directions. Having this port pointed up gives me more flexibility if the computer is on the left and the monitors are on the right, or the monitors are on the right? Then you don't worry about the problem where, what if the computer is on the right side and the monitors are on the left side? Then with the Thunderbolt port here, then they go through, they cross each other. Or am I just being lazy? No, I think that's valid. You don't know what the orientation will be, but they most likely will not be the same. And having Thunderbolt be on the top gives me the most flexibility. right? In any case, right? If the monitors are off to the side and this is positioned, if, for instance, we positioned the eGPU case this way and we put the laptop in front of it here, then you could have the monitors off to the side and this top would still come down into the computer without, and then if this were lower and pointed out the same direction as the monitor cables, then they'd be going out, right? In the pathological case that you have a gazillion, you have all the monitors plugged in, right? If you didn't have all the monitors plugged in, it wouldn't be that big of a deal. But in the pathological case where you have all the display ports, right? 3 display ports and the HDMI, so you've got 4 cables coming out here. If you had the laptop sitting up here, then the top cable could still come over, route over unimpeded. Whereas if the Thunderbolt port would have to be here, right? Then that would have to run directly across, right? And same if you were in the other direction or whatever. I think having that Thunderbolt port not be on the same plane as the monitor ports makes sense. Okay, so I'll leave it the way it is now. All right, so that's then GPU here. This guy will get placed like this. You plug in from the top. Yeah, that should work. That should work. Right, because if you imagine, go back, right? If you're positioned like this and the laptop's sitting in front, the monitors are to the left, you would have then cables, especially if you had 4 monitors with cables shooting out this side, you'd rather have the Thunderbolt coming off from the top rather than from the middle of those connections, because the Thunderbolt NVMe can only emerge either here or here. There isn't enough space here for me to put it at the top, because then I'll run into these captive connections. Okay, so that should work. That means that I should be able to cut now. I should be able to cut the bottom and the front and test the majority of everything, meaning the port alignment and the NVMe mounting. The only thing that I won't be able to check, right? The left and the right sides, I still have to model in fans, particularly what I'm calling the right wall, right? Because these ports, the back of the card in a normal PC setup is the front of the case for me. I'm having the ports face me, right? So this is the front. The right side definitely needs vents. And then the top is going to need a bunch of vents. And then I'll put a few on the left side also. Although the routing of air in this, given the orientation of the fins, seems to be from the side out the top. So the places where I need the most air access is the right side and the top, according to my model. That's relatively easy to model in, and that's not a big deal.
Rufix has invaded the chat.
Okay, so yeah, so maybe we get a little bit more excitement now. Let me prepare the front and the back for laser cutting. Let's hope I have enough acrylic. Okay, so hide these sketches. Be away. Must be a way to get rid of all of these junk sketches or move them, get them out of. So annoying to have to scroll by them. Turns out if you deactivate the timeline at the bottom of the screen, then you're allowed to rearrange your browser tree however you'd like. Beware because it resets your timeline history after that. Oh. Oh. So if I'm willing to sacrifice my history, then I can reorganize my sketches. But if I sacrifice my history and I need to change the position of the auto-generated cutouts, that's going to be annoying. Because the only representation of these operations as a group is in the timeline history. I'm not going to do that now. I will not. I will defer that decision. Okay, so what am I going to cut? I'm going to cut just the front and the bottom. So let me hide all the guys that I'm not going to cut. Save this, and then let's go into the cam workspace. And let's cam out these. So new setup. Machine is not a milling machine, it's the Glowforge. And the orientation for the front, let's make this the front, set XY. The x-axis is this. y-axis is this. Flip the x-axis. There we go. The model is just this guy. Okay. I want to do 2 operations. 2D profile.
All right. Bloodlust has invaded the chat.
Using the Glowforge cutter. The holes first. Whoops. No lead in, lead out, because these things don't make any sense in this context. And that's it. There's op1. And another 2D profile of the outside. With no lead in and no lead out. Okay, so this front panel is set up. Selected. Bottom panel. Y-axis, x-axis will be here, y-axis here, y-axis model will just be that body, and we're done. Profile, again, start with the holes. To not see the stock simulation. How do I hide the stock simulation? Am I missing anything there? Oh. That's right. Okay. Let me rename this guy. Bottom panel setup. And then I'm ready to cam. So process. All right, so this is the eGPU front panel. Is the eGPU bottom panel. That. Then let's go to Glowforge. Create new blank design. No. Create, upload from file. And let's go eGPU front panel. Can I cut the front and the side in the off the same panel? Let's give that a shot. Or front and the bottom rather. So where is eGPU bottom panel? Yes. Looks like actually off of one piece of acrylic, I can cut almost the whole case. Let me just do an example, right? So there are bottom, the top, the front, and the back. Oh yeah, I can get the I don't think I can get that side panel onto the same. Can quite get the side panel onto this though. Okay, so I just have to be miserly, right? I think because I don't have to do even if I'm going to panelize this, I don't need to do all the cuts all at once.
Tommy Genuino has invaded the chat.
Okay. What am I showing you? Okay. Let me my stream information is wrong. Oh, sorry guys. I'm totally not working on this. This is designing and laser cutting piece for eGPU with Fusion 360 and Glowforge. Looks like it's science and technology though, because Fusion 360 is not. I guess I could call this crafting. But yeah, I guess category is just science and technology because Fusion 360 is not a game that Twitch recognizes. Okay, let me load up a piece of acrylic and let's see where I want to lay this out on the actual board. Okay, first, just as a Hail Mary, here's the board that I cut out. Oh, this will barely fit. This should fit. Really? This small? It'll fit? Okay, that won't. This really fit? Okay, let's not cut the QR code. Stick this up here. Really? This'll fit? It'll fit 2 panels. In theory, I could cut both the front and the back off of this? All right, let's try it. Okay. All right. I'm walking between rooms here, so my sense of distance may not be uh accurate, but I'm a I am a little surprised. Okay, I should have positioned that a little bit differently. I should have positioned the piece a little lower because there's actually way more margin up at the top there than the camera shows. There's more material up here that is out of camera view and inaccessible. So I should have. Should have put that elsewhere. Okay. Yeah, I should have shifted this. Should have shifted this down. Oh no. Oh, there we go. Okay. That was annoying. All right, audio is back. And noise removal. All right, now there should be some background noise. Next cut I make. All right, let me grab this and then let's bring back this piece. This out. This over. A little fumey in there. Not too bad, but close the door so that the fumes stay in there. And then let's see. All right, now I gotta not misplace the standoffs. Put the standoffs off to the side in the well. So I put the standoffs off to the side here. Let's take a look. Yes, this is the right size. No scaling problems. Wow, this is going to be compact. Which it should be because there's no power supply in there. Get these holes out. And then symmetric, so I'm not too worried about that. So the front and the back are okay. And then I think this lines up. All right. I need a little. This is not a trash bin. That is the homemade lens cap. But I'll use this to capture some of the bits here. Oh yeah, this is going to work. I think this is going to work. Oh, oops, sorry. Bumped that. Yes, that should be sufficiently far away from the edge. Yes, no problem. Plenty of clearance. Okay, good. Good. All right, let me get the other guy then into cut. File. Grab the eGPU bottom panel. Oh, okay. This will also go up and down. So that might work, right? Then if I have two of these, just to measure, right? Right, because the side panels are going to be taller than this, the bottom panel. But this should be wide enough that then I can put two of them, especially because there's more space up here, right? Because if you look here, it looks like, oh, I'm bumped right against the top, but actually there's way more space up there if I shift this down. Okay, so yeah, so this will only take one more panel. Okay, let me go load up another piece of acrylic. which is good because I don't have much of this thick acrylic left. I only have two sheets, so it's good that I can in theory do this on what I have left. So let me put this way up and to the left, as much as I can. Okay. Okay, so I've got this guy positioned. This is the bottom. Ready to cut. All right, magic time. Time to push the button. Camera really makes it substantially easier to position prints or position these cuts compared to what I was doing with like the epilogue printers. Printers. Why do I call these printers? The epilogue cutters at Tech Shop, where you would have to, you'd want to be doing live. There's a live interaction mode with the machine where you want to like, oh, I'm going to position my cut in a certain place and then move the machine's head up there and see what's kind of, the machine has a little visible laser to say, okay, where's the corner? Then nudge, 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 nudge until you reach the corner. Here with the camera, once I understand a couple of things about the camera positioning and the motion system, this is way easier. I have never had to, and I don't even know how to operate the Glowforge in like robot mode and logo mode, where I like nudge it up, down, left, right manually. Getting close now. 7, 6, 5, 4, 3, 2, 1, 0. Okay. Well, that was a long cut. So I think I'm gonna wanna wait. Keep the lid closed for a moment to minimize smell. Yeah, I think I'm gonna wait a bit. Let me go take a look. See if I overshot, which I did not. Good. Okay. Yes. Put this back. Position this for the next cut. Okay. Nice. These guys out. I put this away. Don't need this heatsink. Standoffs away for a moment. Let's do a little weeding. Come on. Go. All right. All right. Let me sweep up these bits, throw them away. Actually, let me sweep up these bits. And this is, I have to do mounting. I have to get rid of this. I can't get rid of this paper board at the last step. one piece here. Moving this could be like an ASMR video. Okay. So shiny. Of course, they won't be so shiny for long. Because I'm not wearing gloves. Okay.
Comrade, Satan, has invaded the chat.
All right, what do I want to try do first? Let me put the feet on first. Yes, I think I will put the feet on first. Should be like this. So let me get the rest of these feet off. So I've got one foot off. Another one of these feet. It's interesting that they took care. It looks like the nuts they used to affix these feet, they almost looked like they were bolt cut. Because they don't just go through. These nuts are capped. And there are two washers to stand these guys off. So it's like I gotta be a little bit careful on this side not to mess up any of the jumpers. Because only the M1 jumper, only the switch one, this one, can actually has any effect. The rest of these guys should not be touched. Oh no. There we go. I don't want to lose any washers and have shorts. This guy. This one. Okay. So this will, in theory, go like this. Flush. All right, so there's a slot here because there's stuff that sticks out the bottom, right? So that goes into the slot. Why does this not sit flat? It's just let me get rid of this film. enough, right? Doesn't sit perfectly flat. It's a little bit warped, but I think that's okay. Let's make sure these are aligned with the holes. All right, now, these are the feet, but these screws are too short now. And using these capped nuts, I think, are a little bit too finicky. So let me go get that set that I bought from Amazon. Where the hell is it? Oh wait, I was out at dinner last night when it arrived. Is it in my mailbox or is it out front? Let me do a quick check. Orders. Oh, never mind. I took it in. Here it is. Of course, the next famous global brand for M3 screws, Schkm. SCHKM. No vowels. Okay, so I think this is the right height. What is these? Those are the 16s. I guess these are the 16. I guess these are the 20s. All right, let's see. That will go through here. And then up. Why are these a little tight? Why are these a little tight compared to... Oh no, it's this hole. That hole is a little tight. Some of these are a little tight. These two in the corners. I think they just need a little deburring. Scratch. I think it's just a little deburring. More than... And I can screw through. Okay, so I need... one, Let me do a quick sanity check. Make sure that these stick up enough, but not too much. Whoa. No. Actually, they may stick up too much. I may not need them to stick up this much. But I don't want them 4 millimeters shorter. What's the next one down? So these I guess are the 20s. And then what about, these are what, 16s? All right. I'll try the 16s. I'll try them on one that's a little bit easier. Let me try this one here. Like the original ones were 16s. I think 16 is going to be short. I think it looks like the original ones were 16s. 12, 10, 6, 8, 10, 12, 16. Yes, this doesn't seem to stick up far enough. Let's just continue with 20s. That seems like the best bet. Yeah, I guess those were all 16s. Okay, that's fine. How far down do these? If I use the original screws with the original washers. Well, I don't have all the original washers. I seem to be missing one. I guess that's tight. Yeah, okay. I guess I can use the originals with the washers. Oh wait, I have extras. Because this box comes with washers. So that's fine. Oh, actually, and I have them all anyway. So I'll put 2 washers in. Tight. Okay, good. And then the other 2. The more complex side with the cable sticking out. Let me do both of these at a time. I'll stick this through. There we go. There's 1. There's 2. Okay. We're in. Washers on. 2. 4. So this guy gets stuck.
Comrade, Sonia KG5YFZ has invaded the chat.
And 2. Okay, nut. Come on, go on. There we go. Nut, 2 nut. Okay, so almost done. So this first step here basically affixes the ADT-Link board to the acrylic base. And this forms the bottom of the acrylic enclosure that I've designed. And this forms the basis with which everything else is going to get attached. Okay, good. And this is, yeah, there's no play. Good. All right, so this now forms the base so that if I need to eventually make any changes, all I need to do is change the sides. And the standoffs are good here because the screw heads are going to stick out from the bottoms here, but it doesn't matter because now we've got the feet. The feet will hold this thing off the surface. All right, actually, this guy is annoying, and I'm actually not going to use it for a bit. The one missing link is I need to have a cut open here for a the power supply, the DA2 goes into these pins here. There's six, the first 6 pins on the second connector here, and I want to be able to plug it in from the back. So I've got this ATX extension coming. What's it getting here? Monday? Is it really getting here on Monday? Really get shipped, or is it just shipping label? Pre-shipment, no shipping received. The acceptance of your package. Well, we'll see. Supposedly it's supposed to get here on Monday, which is a 20-pin ATX connector, which I'll then use the ultrasonic cutter to cut down and act as an extension cable so that I can take the 6 pins that I need here for the DA2 and then extend them out the back, that side. And so I'll need to cut a hole on there. And I'm also going to need then access to plug in, because I've designed this compact enough that I will not be able to do work on these while the side is in place. So I probably will end up putting in this wall last. Okay. All right, and I guess I'll store the 16 millimeters in here. Now I have extra 16 millimeters. Okay. Now I want to, let's see if this lines up. What is wrong with this? Something is wrong with this. Fuck, where's the slot? God damn it. How did I miss this? Where's the slot? Oh my God, I am an idiot. I forgot to cam. Forgot to cam.
Academy Impossible has invaded the chat.
God damn, I forgot to cam the slot in the front to access the. Ah. Got to cam. call this eGPU front panel. Arg. Arg. I forgot to cam the slot. I was doing this work here. I forgot to cam the slot. I just fixed it and regenerated it. Now, an interesting question. Arg, how did I not notice? How did I not notice? How did I not notice? Okay, now I gotta see. How did I not notice? Now, this is only approximate. So there's a chance that I could stick this back in and just cut that slot. Can I do that? Gonna mess up the finish a bit because I took off the paper, and so the smoke is going to get on the clear part, and that will certainly show. Okay, so I want to figure out, let me show you what I'm doing. See if that convinces myself. There's parallax in this camera. You probably can't see, but basically the camera that we're looking at is this camera here that's right in the middle of the Glowforge, right here. And so there's parallax in the camera, so the alignment's not so good on the edges. It should be better in the middle. So if I can place this in the middle, then should be able to get the best possible alignment, the visual alignment. But then how do I make sure that I am straight, right? Then I need a reference edge. I need a reference edge. Something parallel. That I know is like machined parallel, or oh, okay. There's also a second backup plan, which is I have more of these smaller pieces, and this looks like it'll fit, yeah, on the smaller piece. if I needed to. It's not quite where I want it. Maybe this is good enough. Let me just get it then left, right, as close as I can get. Let's see what this looks like. Backup plan, yes, there is a way that I can cut more of these side pieces without digging into the other giant piece. Okay. All right, so there is a shadow. You can see the parallax. Can I line this up? This guy. Left right parallax, I think I'm getting here. Top bottom, it's not symmetric, right? The bottom is closer to the center. Right, because the center of the camera is not here, it's more like here. I think this is the best I can do. All right, so this guy, don't want this to cut. We want to get rid of this. Ignore this. Ungroup this. Do not want these cuts. I just want the slot. Okay, what I need to do is make that slot a different operation. So let me get rid of this, Come back here into the cam view, 2D profile, right? This guy. All right, let me edit this guy. Geometry. Let me deselect this. Let me add the profile. No lead in, no lead out. Just the slot. Put the slot second, let's say. Okay. Well, let me generate this. eGPU front panel. This is a Hail Mary. But I'm curious because I've always wanted to try this, right? To see whether or not I could align multiple cuts. Since this piece is scrap anyway, I might as well try it. Let me upload front panel that's got 3 operations. So I'll align these guys. Left-right parallel is about symmetric. The left-right parallax, rather, is about symmetric, but the bottom is better aligned than the top. I don't even know how much I'm nudging by. If I zoom in, I adjust the amount that I nudge. Nope. No, no. Oh, that's Windows key. Sorry. So obviously Windows key isn't going to do anything. What about Control? Shift moves by a bigger amount. Alt doesn't do the right thing at all. Whoops. Glowforge keyboard nudge. Glowforge keyboard nudge amount. Keyboard shortcuts. Little nudge, arrow key. Big nudge, shift arrow key. Come on. Place designs precisely. Use the precise position tool to arrange your designs. Sign in and open a design with multiple. Click on an element. The precision position tool will appear. Really? Okay, there is the precision position tool. These are 0.5 millimeter increments. That's pretty close. Okay, so this is as good as it's going to get. Let's do this. All right, and then I'm not going to recut the holes, just the slot. Here goes nothing. I mean, I did do the precision alignment at some point in the past, but I mean, even if I got this alignment right, I mean, the problem is that the alignment of the laser to the camera, right, like where it claims this cut is going to be made, isn't where it's actually going to be made. And how off it is, I guess if I knew, I could have looked. Well, no, because I was cutting on the edges, and so there was no way for me to measure. All right, let's see what happens here. At least the cut will be parallel. It'll be square with respect to the piece. That I'm fairly certain of. The problem is going to be whether or not the cut is positioned close enough for me to access the ports. I have some leeway. That's not bad. The smoking is not terrible. Doesn't look terrible. It doesn't look terrible. Didn't cut through. Fuck. Didn't cut through. Oh, I didn't look to see whether it was aligned.
Comrade, MetaViews, has invaded the chat.
The positioning actually is really good, but it didn't get all the way through. It didn't get all the way through. And I don't know if I'm going to be able to correct this. This knife is not going to be thin enough to... this would have worked. Lesson learned. Without the paper on, I need more power. I need more power. Yeah, it didn't cut through. And I think it didn't cut through. It's off by a significant amount. I think it's only... Yeah, it's not like it's barely there. It's only maybe halfway, maybe 3/4 of the way there. There's a lot left. Well, that is unfortunate. I'm gonna have to expend another piece of acrylic, but I can expend one of the smaller pieces and not a big board. Yeah, it won't fit there. I have to rotate it. This way. Okay. Refocus as I put a piece in. Okay. Okay. Oh, wrong view. Yeah, I'm gonna have to expend another. It's okay. Arg. So that so close. I could have done it. And actually, the amount of smoke not is not bad. Yeah, the alignment of this is as designed. It would have worked. It would have worked. It would have worked, but it didn't get through. Oh yeah. No, it's not even close. Not even close. All right, more magic time. And I ate too much for breakfast. I should have had only one pupusa. But I just felt a little bad going into this nice local little indie place and ordering so little. Instead of ordering 2 pupusas and a jamaica, I should have had 1 pupusa with water. But a pupusa is only $3.50 a piece, so I feel bad ordering so little. Let me get water. much time is there? 32 seconds left. Oh, so sad. This guy is scrap. The right tool for the job makes this much easier. This is the right tool compared to the pliers, because I can push all the way through. Because why I love the laser cutter. I mean, I've been using the laser cutter for maker projects. I've been using the laser cutter a lot more than the 3D printer lately, because the laser cutter is just so fast. It's so fast. I can do so many iterations. Errors like this are not like, oh no, I made a mistake in my CAD and now I have to print overnight. Do another overnight print to get the corrected piece. Okay. Now. Yeah, the positioning is just about the same. Just about the same as the one that I fixed up. Order of operations. First, I mount this guy with the standoffs. And then second, what's this? All right, throw this away. I'm just going to have my failure staring at me. Goodbye, scrap. Okay. So this goes on like this. So this is going to be on the inside like this. All right, so what is the size here? 5.6 plus. Plus 6 millimeters. All right, that's about 12 plus the thickness of the board. 1.6, 13, 14.
Itron C. Set for an analog caliper.
14 plus 3, 17. So I think M16 is the right length. Yeah, analog caliper. I love this because the batteries never run out. And I don't need so much precision that I'm worried about the changes in measurement due to a difference in temperature. So it's true when the ambient temperature is different because all the things, everything here will expand and contract with respect to temperature. The analog calipers do not take that into account, whereas digital calipers do. The mechanism by which even the cheapest Harbor Freight digital calipers will always measure the same regardless of the temperature. But I love that I do not need to worry about. First, I can read metric and imperial off of this. No switching modes. I can read it off in one and no batteries. So I think 16 millimeters is the right length here. Let's stick these into 3. All right, let me drop the spacers down. And this is in the class of like cheap made in China tool, but it was moderately expensive from Amazon. But yeah, I get so much use out of this tool. And then slot this guy in. Okay. This works for the top two. But not the bottom one. Bottom is our cross-threaded. Come on, straighten out and get down there. Yes, the number of like these tool reviewer channels have reviewed the difference between like the ultra cheap Harbor Freights and the really good quality like $100 to the $200 Mitsutoyos. And the main difference between the cheap Harbor Freight digital calipers and the Mitsutoyo calipers is entirely the battery life. The Harbor Freight ones, they burn power like constantly, whether they're on or off. And the Mitsutoyo ones have some primitive but effective, because the Mitsutoyo calipers are also, they were not exactly designed recently. The digital calipers their design is still pretty old, but they are primitive but effective in having long battery life. But if I had like $200 Mitsutoyo calipers, I would need to like keep them in the box and take care of them. So this is not a cheap $10 caliper. This was like, I think maybe $40. It's in a different class where I'm okay just like, putting it wherever. Okay, I need a longer screw. So 16 isn't going to cut it for this one. I'm going to need the 20. the bottom one. The 20 sticks up a bit much. What if I got... I remove this foam. Oh, what the hell? What the? Well, that's no good. All right, I'm not removing this foam. Hard to see here, but under the foam, real close to the hole, is a resistor and an LED. It's close enough to the hole that the nut will be on top of it. So when I I need to screw this nut down, not very tight. I'm going to have to screw this down loosely. It's probably not critical. I mean, it's an LED and a resistor, right? So what could it be? It's probably the LED to indicate drive activity. And if I crush that LED, probably nothing bad is going to happen. Okay, so what I will do is, I will not remove the foam. I will leave the foam in place. Sorry. Let me slide the spacer back in. Then I will use a 20 millimeter screw. And then I will only will gently tighten this end down. Right. And then okay. Okay. Yeah, and that's fine. Right? I just need it not to be flopping. The main thing, it's got to resist getting pushed down when I'm inserting the Thunderbolt, and resist being pulled up. When I come back up, when I pull it out, gonna go in like this. And yeah, it's not slamming into anything. See how it goes. Yeah, so that's gonna work. And then this, yeah, this is good, right? So this also, the
Hytron C said, "Whoa, is that metal plate thing warped?" Hytron C
yes.
said, "Or is it the plexiglass?"
No, it's warped because it was stuck on, it was affixed by glue to the plastic case, not to the PCB. So I had to rip it off, and then I used some silicone tape to stick it onto this side. Now, should I? Nah, I don't think I need to. I used double-sided silicone tape here so that it wouldn't short. I'm wondering whether I should also apply conformal coating to it. But conformal coating is not flexible, and this thing is a little flexy. And then I might generate dust. I think I will. I will leave it. Okay, this should be tight enough that it doesn't fall all the way through. Position this over this way. Where's my screwdriver? Oops, it escaped. Okay. Good. Now I've got. I can mount this. Little cable tie. That in. Okay. Oops. Then I think there's enough strand relief here, but I will add a little bit more to keep it from, because I'm going to need to probably going to wind the cable like this. Put a cable tie here. Oh. Cable tie here to keep it from bending down too much. I really hope that I don't short out that NVMe board. It's interesting the order of like what was the most expensive here. Like the ADT board here was $57. The NVMe board here, $65. Next most expensive thing, all these screws. The 632 screws was $20. And then the cheapest item was the power supply, the DA2, which was $12. Okay. Guy up. Don't think I'm gonna need any more M3s for the rest of the build, since everything else now has been oh, this isn't gonna work. This impedes the wall. Okay. I need to take this cable tie off and reposition it. I don't have the nub facing this way. Do this again. Eh. Isn't enough clearance for that. I didn't put enough clearance for there to be a cable tie here because I was worried about running too far that way. So there's enough. Actually, I'm a little low on clearance at the bottom too. Oh, it's because of these things sticking out. I didn't factor that in properly. It is close. Okay, so the cable tie is not the problem. The problem is these two, these two protrusions here. I didn't model enough clearance in, but it should be okay because there's some lateral play here with the captive nut, because the captive nut arrangement allows a little bit of play left and right here. And then what I can do to try to, as much as possible, that isn't going to do anything. That's fine. That's as good as it's going to get. That's okay. I think this will be okay. I don't think it'll be a problem. If I were to remodel this, like if I had one more millimeter, it'd be better.
Possible to melt down. File off some clearance.
Oh yes, right. So if I had to, I could file off these these protrusions off the PCB because FR4 is really easy to file. But I think I won't even need to do that. I think that it'll just be like half a millimeter because it's not much. It's only about half a millimeter or so. The wall will be stick out just a little bit. I don't think that will materially affect the strength. So we've got this. There's enough clearance here, right? I did not make a terrible mistake. I thought I measured this. And it's not quite. Not. Okay, so this is the problem. There's enough clearance here if there were only one GPU power supply coming out of this. But because there's two, I don't need to. Because there's two, it's a little thick. Little thick. Little thick. Space. Barely. That's one thing that the CAD design does not account for. is the yes, it's one thing that the CAD doesn't account for is the why did I guess I didn't clearly measure how much more the connector end would need. Close. It's very close. If I had a GPU power that was just 1-to-1, I think the radius would be sufficient. Um,
High Trance C said, maybe time to cut an extension section for the enclosure.
wouldn't necessarily need an extension section. I just cut it open. I could just cut a slot here. Oh, except that one of my
High Trance C said, true.
except that one of my captive nuts is right here. Let's see, so this guy's here. That's okay. This guy. If I push it this way, it's the max, right? Problem is the thickest part. Thickest part is right where the captive nut is. So that's an interesting question. Right where the captive nut is. Now the captive nut, this long thing here, it is cut in. So if it is exactly aligned with the slot, there is another 0.5 millimeter or so where it can go in and instead of touching the wall, it'll push against the nut itself. And the nut is inset. I want to avoid recutting the base. The base is long enough. I think this will be okay. I think this will be okay. See, the worst case, maybe since these are so, maybe it's not worst case. Maybe I should just do it because it'll clean up the cabling a bit. He just cut off the second connector.
iTrans C said, new cable.
I thought about that because ideally I was going to say, well, can I buy one that just comes with one? But that seems to be an exotic item. I searched through Amazon and eBay.
Said, the white still sticks out.
Yeah, but I think that's okay. I think it's the cable radius in particular of this of when the when more than a couple of these overlap. So I think this side is okay. Wine's flat enough because they can splay out this way. This one on this side here is the one where there's too much, where in order to bend through here, there end up being like 4 cables overlapping, and that's too thick. I think I can just cut this end off. And that'll also, I was trying to figure out, well, I have this dangling thing, so that I don't need.
C said, you could also split that end.
Yeah. Well, no, there isn't enough clearance for me to get these out.
C said, I cut down the cable of the one you don't want so you can split it in half.
Oh yeah, I mean I'm thinking that I just also to make sure that I don't have shorts, I'll just cut them real short in here and then leave them in there. All right, just with wire clippers, just cut them down. Because this is a pretty commodity cable. So realistically, if I needed to no, the design would be completely different if I needed a more powerful GPU. Because a more powerful GPU could not be powered by the DA2. And so the whole design would be somewhat different, would be bigger, because then it would be an ATX power supply. Yeah, so then I'm not too worried. I'll just cut this cable down. And I'll do that now. So that I also don't have to deal with figuring out how to
iTrans C said, make sure you cut the right one.
yeah, this is the one that I can't.
iTrans C said, or are both sides the same?
Oh, they're both the same. This is just supplies all of the both ends are both ends are the same, and they are crimped together into one plug just to parallelize the power. I'm actually not sure why it happens to be designed this way, but all of these GPU power cables seem to be 2-to-1. So let's see. Because at the top here, essentially,
for multiple rails.
yeah,
iTrans C said, maybe.
like a 2080 just has 2 of these that are the same.
Work.
Oh, that went flying.
iTrans C said, is hot glue a good enough insulator? Lol.
I mean, for 12 volts, there's nothing here that's more than 12 volts. So, yes. More. Now they're too short to short each other out. Now let me do one more rough test. Yeah, so now that can sit flush. So this will work. Okay. Same will be true for the DA2 extender. Extension cable that I cut down, given just a single set of wires, should be able to then fit. Yes, because if also there were just a little bit more space before these guys get bundled up, then I'd be able to maneuver the individual strands so they don't overlap. But this is good enough. Oh yeah, plenty of clearance now. Now I'm like a millimeter in. So long as this thing still works, which I suppose I should test. Now that it's mounted up, I should test that I didn't bust the NVMe. I have to be a little bit careful of manhandling this. There's only 2 screws holding this. It'll be a lot stronger once I have a third wall in. Okay. Let me clean this up a bit. Clean up the workspace a bit, and then I'll bring the computer back here. That'll be fine. There's plenty of opportunity. This cable is so flat. Okay. Just even having this whole thing now with the NVMe attached instead of this piece here flopping all around is way cleaner than it was when I was prototyping. Assuming now that this works, plug. Plug the DA2 here. This, which I will use this ultra short cable for. Get my computer. Yes, because even with the shortest possible cable, and the actual, I can cable up at 40 megabits with up to a 3-meter cable, I think, which I won't really need. And then actually, I'm curious. How well I can access ports back here, just for fitting. So can I get at, well, if I took the second rod out, this rod here impedes access to the ports. If I took that rod out, I could get, that should be, even that top display port that I thought was going to be tricky, I think I can still access it. Minimally, I can access 1 HDMI and 2 display ports. I think the third display port I can still access also, but you know, I mean, an eGPU setup in a mobile setup, I'm almost certainly never going to need to use all 3 of those, all 4 of these ports.
Trans C said, probably don't need this many
Yes.
outputs.
So I'm not too worried that the top display port, the third display port, might be obscured. Okay. That's it. Let's see if this works. What do I need to do? I need to plug in the power supply because it needs to be on at boot. All right. And then, so we're in here. I got to hit this Apple Set OS EFI and ping it a couple of times. And this sends a signal down the PCIe bus that'll prevent the internal GPU from getting disabled. Then I can go over and boot Windows. Should be working. The fans are spinning. The fans are controlled by whether or not signal is coming through Thunderbolt. So if the Thunderbolt card is not working, the fans will not turn on. All right, let's boot into Windows.
Trans C said, is it possible for the laptop to supply the power to the eGPU? Or is PD not enough?
No, PD is not enough because even the 3080 needs like 160 watts. It is possible for the reverse though. So a real, some of these commercial eGPUs will supply PD out from the eGPU. So the single cable setup for eGPU is usually you have a much more powerful power supply on the eGPU side, and you feed PD out along with the Thunderbolt. But that would mean, for me, that would mean dealing with the ATX power supply, and the portability of using the DA2 was just irresistible.
Trans C said, super complicated, haha.
All right, this does not look promising. Where's my Nvidia? What is missing here? Why am I not seeing anything. Uh-oh. Hmm.
Hytrans C said, is everything plugged in? Hytrans C said, with the white connectors.
Should be. This is my power. This is the Thunderbolt going into the card here on this side. Why did I get it? Oh, there it is. Okay, so the NVMe device works, but the boot sequence didn't work properly. So I get right. This is the problem that you try to evade, which is the device cannot find enough free resources that it can use code 12. And code 12 is the one where there's not enough PCI address space. Okay, so nothing wrong hardware-wise. It's the same old software problem. Does it not work on the first time after boot, or was there some problem because I powered on shortly before, after my computer turned on? I don't know. Let's try this again. Spam this a few times. Okay, at least I didn't break I didn't break the PCIe NVMe adapter. I didn't short it out. And it's not shorted out right now. That's good. Because otherwise it wouldn't have been able to propagate all that data. And no, it works now. Here we go. Now I got the Nvidia settings. Yeah, so these taskbar icons will only show up when the 3060 is detected. So like the first time I didn't, because what I do, I flipped open the lid on my laptop, and then I plugged in the power supply back there. Maybe I just didn't plug in the GPU in time for it to be detected in the boot sequence. I just plugged it in too late. But yeah, system information, 3060 is here. And because it's on the right side, it shows PCIe Express X2 Gen 3 instead of X4 if I had plugged it in this side, but that's totally fine. Okay, so this works. I didn't break anything. Yay. I didn't break anything. Okay, good. So this fundamentally still works. I just need to finish the packaging. So, left side, right side, and then back and top. Left side, right side, back, and top. Okay, so what can I definitely not model right now? What I can definitely not model right now is the back, because my DA2 extension cable is not here yet. And I need to measure it after I cut it down. Cut it down meaning it's not actually a DA2 extension cable. The DA2 pin out are 6 pins that are oriented, that have little trapezoidal orientations that match a bank of 6 pins on a 20-pin ATX connector. So I ordered an ATX power extension cable that I then need to shave down to just the bank of 6 pins that I need. So that is going to go out the back panel. I need to measure that after I cut it down. The top I have, I think I have made an error also. I don't have enough clearance for the top. Okay, so I have made an error. I have to remake the front panel. I don't have enough clearance in the top. Although for $8 I could, although for $7 I could buy this. That's tempting. Not just so that I wouldn't have to recut, but it would keep, it means that I wouldn't have to, it keeps the overall volume lower. Yeah. Maybe I should get this. This is cool. Why, why are there three different this is, I see, 6 pin to 6 pin. 6 to 8, 8 to 8. What is this? This is an 8. And at the bottom, also 8. Comes with 2 of these. And that might be too far the other way, but okay, this is, okay, I'll get this. Is this oriented the right way? I think so. Right, the trapezoid side pointed down. And that means it should hang down. Then I plug in from up, and then there's nothing hanging in from the top here. Hope that's enough clearance. I modeled in some clearance, but I might not have modeled. But clearly, I didn't model in enough. I didn't think about how these connectors are so chunky. Low profile 90-degree 8-pin to 8-pin. Oh. Yeah, but then I have to this is going to come from China. This thing is not going to arrive anytime soon. Estimated between October 22nd, because it's going to be shipped slowly. So here's a single GPU, but I don't need that. Okay. Okay. This 1, 2. Sorry, this is a funky connector. That's not going to work. I'm not going to be able to find a thing for the DA2's input. Yeah, so I cannot cut the right-hand side. Pretty dicey, actually. I'm not sure I can cut any of these sides until I validate that this low profile connector is low enough profile. It should be. It's hard to be sure. Okay, so definitely going to buy this. Tech. Established in San Jose. They're local. Oh, but they're B2B. No handling fee on orders over $100. I don't think I need $100 worth of these. I would have to pay the handling fee. Please contact us for a quote. Yes, I want one. I guess I can buy a sample. G-Power. ATX 8-pin to mini 12-pin. What do you mean mini 12-pin? The RTX 3060 doesn't have mini 12-pin. There's no 12 pins. What? That doesn't make any sense. What is mini 12-pin? That's definitely regular GPU 8-pin on this thing. Overnight samples. I do not need G-Power, GPU premium cables. I don't understand. What is this right angle thing? No, I think the thing that I bought is the right thing. That would also solve the problem on the ATX end. It would flip it over, right? And because I don't want to, 90 degrees would not be right. Because 90 degrees would not be low profile. Right? Because the amount that it sticks out from the socket now is only the height of the PCB plus this plastic piece here. The fact that the conductors are on the PCB, I think, means that this is the lowest profile option. It's too bad the DA2 connector is so exotic. Otherwise, another one of these would be ideal. Okay, I think that solves the problem. Should solve the problem. We double check. How much clearance I modeled to the top. This is the plane that I modeled. The definition of this offset plane is what? Okay, 5 millimeters from this topmost part of the 2080. Okay, that is real borderline then. It's almost certainly the 2080 is bigger than the 3060. However, I don't know if this is enough clearance, so I would need to measure it exactly. I can. Okay. Anyway, this hardware-wise, I didn't break anything. So let me shut down and get the computer out of the way. I know what I can do. Do not have to print the back panel. I'm only testing for fitment. So here's the broken the misprint, the miscut one. Plug the power supply, unplug the Thunderbolt cable, unplug the DA2. Okay. Right. All right. What I need is, gotta be careful not to break this. Sides are not on. I put this on this side. Then I can see how much clearance I have by laying something across the top. This for the moment. Then me this guy on. now I've got two sides on. Now I can measure how much clearance I have. And that is okay, less than a centimeter. 5, 6, 7, 8.5 millimeters. That should be enough for that low profile connector. And then what if it's not? If it's not, because I just need more height, I could design little standoffs that are 5.6 millimeters wide, kind of long, and then have holes in them, right? Right, that might have a hole and then maybe extend out a centimeter in either direction. The profile would be right. I just cut a square piece here, have a hole in the middle, and that would stand off another 5 millimeters. And I could just put them, cut a whole bunch, design. The part would be simple, right? It'd just be a square with a circle on the side, and then I'd have to design. I'd have to cut 1, 2, 3, 4, 8, 9, 10, 11 of them. And that'll raise the roof a bit. And even add a little bit of venting in the top. Okay, yeah, okay. That'll work. So I have a plan either way. Yes, either way. I can use standoffs to raise the roof. Because the roof does not have anything coming in from. The reason why standoffs will work for the roof is because the roof is entirely holes. There's no there's no captive slots in the top and bottom. Right? If there were captive slots, then I can't stand it off. Because it's not laterally, right? But top and bottom will work. Yes, okay, good. Right. So the height of the case I can take care of. I can adjust that and raise it if I need to. Right, because I have 8 millimeters now, and I can add 5 more. I can add more than 5 more with multiple standoffs, right? And then oh shit, that won't work. I'm an idiot. That won't work because of the way I parameterized these. Ah, stupid. That won't work because of the way I parameterized these captive nuts. If I'd parameterized these captive nuts so that the nut capture was lower, I could do this. But now with the standoffs, the screw won't reach the nuts. Ah, that was dumb. That was dumb. That was dumb. Ah, that was stupid of me. Right. Because now I'm maneuvered in. I have no room to maneuver because these captive nut, if the screw head is raised a bit, then it won't reach that nut. If I had chosen the option that had more stick out, then the nut would be lower and then I have more space, right? Like the nut could easily be, this nut capture could easily be 5 millimeters lower and there'd be no difference. And that would give me then 5 more millimeters of leeway. I only have 2 millimeters sticking out from the top. So I only have 2 millimeters of leeway. I can only shim it by 2 millimeters. Only shim it by 2 millimeters. That is the limit. I think that should be okay. I think the reversers anyway means that I don't need any shimming. So I can't shim it an unlimited amount. I can shim it 2, maybe 3 millimeters. Well, lesson learned, if I design again, I need way more leeway. Because having that leeway is like totally free design element. There's no reason not to have more stick out. Okay. Not too bad still overall. The happy path, everything still fits. The worst case, I recut everything. I do have enough material to recut everything because in theory, I can cut everything on, because I can cut the front panel on the small ones, right? I have enough material to cut a whole new case if I had to. I mean, I have even more, right? It would just be a little bit more complicated because I have the scrap materials from Tap Plastics. I have to do a few measurements on those to make sure I have the right measurements. Um, but that's good quality cast acrylic also. So I think the right thing to do, is to proceed, right? Yeah, I don't need to wait for anything. I can even leave the back this temporary back on. Um, right, I do not need to wait for anything. The right side and the top, for sure, I can continue, right? Because the top is about the top part, Thunderbolt side here. So I just got to make sure to cut out um, space for it, and then the little PCB that sticks out, right? So right, because the standoff is below level, but then this PCB part here is. Let's double check here. Yeah, everything is below level except for the Thunderbolt connector, but I need to leave enough space around it so that whatever chunky housing is around the plug will work. So I can continue with this, with the top and the right, and the left. Right, because the only thing on the left that's not certain is whether I need any relief to let any little blobs stick out. But I'm constrained design-wise. I'm constrained design-wise by the position of maybe on the left side. I should move. No, I can't move it because I already because I already have the bottom printed. I don't want to reprint the bottom, right? So I can't move it. So all I can do is potentially cut some slots for relief around the joint. And that's it. Nothing to measure against. Right, nothing to measure against. So cut some relief, and right, that'll act as ventilation also, and that's the best you can do. Right here, and around where the
Comrade, Datalore_TV, has invaded the chat.
right. Yeah, so I can continue. Okay, I will continue then. Back to the computer. So, well, I have more height, right? So the clearance, the RTX 3080 is 3 millimeters shorter than the 2080, but in reality, I don't want to change anything now because it's parametric, but I actually want, if I were to do this again, I want this offset plane to be a lot higher. And for there to be more space on the left-hand side. But so far, so good. It's a good thing I tested these, right? That way I can order the alternative parts. I think with the low profile adapter thing, I think that should be fine. Or rather, the power routing will be fine. So I can do the sides and the top, everything but the back. Let me take the front off, put the right wall on. The right wall is pretty simple. All I need here is ventilation. So I'll create some slots. About the positioning of these slots. Make some construction lines first for me to align against. There. Do the same thing. Ah! Do not hold it down. Just click. Point to midpoint. Midpoint to midpoint. I believe I distributed these evenly. don't think actually I want to put them here. But you don't want the slots aligned to where the material is the thinnest, right? But I'll just grid these out. Slots. Let's put them over this. Ah, no. That. these slots, the ends. Set. Yo! A set of slots. Oh shoot, I don't want them. Arg. Arg. Oh. Okay, let's go back. Undo, undo, undo. All right. Let's fix these slots. Ah.
Lily Red Wolf has invaded the chat. Comrade Lacey likes XX has invaded the chat. Comrade WTF Steve has invaded the chat.
Is something? Yes. We're gonna actually need to cut these out, so they should not be construction lines. And what the hell? What is going on here? Not construction line. Okay, so all of these can be cut, but do not understand why, what the different coloration means, but that's okay. Let's take these guys and let's mirror them across this line. Okay. Take these guys plus the ends, mirror them over this line. Okay. Take these slots. Okay, so this is my pattern. Yeah, that'll work. So let's go 1, 2, 3, 4, 5, 6, 7, 8. 8, 9, 10, 10, 11, 12, 13, 14, 17 holes. Let us cut direction to object. The other side. Okay. I think I can get one more in. See, let me take this slot. Let me line. It's a little close. Let me see where the fans are. I don't think this will significantly weaken the case. Pressure is going in the other direction. This guy, center line, mirror line, the center line over here. Okay. Let me modify the extrude. Add in this guy and this guy. Okay. All right, that's nice, and that's a pattern, and it doesn't trigger my whatever. It doesn't seem to trigger trypophobia. I hope. Okay. That's good. I think that's good for the right side. And front is done. Let's take a look at the top. Rename this guy. This guy is right panel features. This guy, create sketch. Okay, so I'm gonna need off the top. To get some construction lines here. See this, this, this. Ah. Should be enough. Got my construction lines. Let's go back to the top and turn off the other walls. Well, maybe the front wall here. Okay, I'm gonna need to project these two also, because that's where the that's the center point. The center point is where the Thunderbolt connector is. So let me turn off, leave the front wall, turn off the top. I want to project, see it from here. There's a way to, you can set the center rotation with some key command. Cannot remember. what it is. For now, let me just project. I want to project that should give me two. All right, so it gives me the circumference here. That's fine. So I'm going to have to create line midpoint here. Stick out to here. Same thing. All the way out to the other side. Degrees. Okay. So that's the dimensions of the board. And then how far in is the center Oh well. So the Rode Wireless Go ran out of power. Okay, so back to internal mic. That means no talking while I'm at my printer. Let me go put stock into printer laser cutter. Now I'm gonna go put stock into the laser cutter. I need to keep that door closed because it's kind of hot outside, and I have to leave the window open in order for the fumes to vent out. So plays one guy, right? Okay, so here's a side panel. And let me add top panel. And all right, that's the left panel. So now I need the right panel. Okay. So that's the left and the right. This is the top. So let me rotate the top panel. I'll put this here. Right. I'll put this over here. This over here. Okay. That's about everything that will fit. I don't want to cut over that sticker. I'm going to move the sticker. I think this is going to work. Let me move the sticker. Okay. All right, stickers out of the way. We've got the cut set up, so it's first inside, then outside, inside, then outside, inside, and then outside. Yeah, that should work. All right, let's get this set up. And then cut. That's a 20-minute cut. Proof grade material in the front. Yeah, well, whatever. It totally is proof grade material. It's just that. Yeah, so it's hard for the camera to read the QR code when it's off to the side. And there's the cut. This camera's been pretty stable. So this is the OBSBot. In a more stable configuration than what we used for Anti-Cloversary 2. It's not that stable when it's connected to the Wi-Fi access point. It's best when my computer connects to it as an AP. And then instead of using FFmpeg to read, or instead of using FFmpeg from OBS to read, I can apply some custom parameters to reduce latency. And feed it to an SDL window, and then I'm window capturing that from OBS, and that is the most stable configuration. And it also results in latency, even though it's over Wi-Fi. The latency is the same as the wired cameras. So it makes it easy for me to sync up multiple cameras. Hope this pattern doesn't make what this isn't is there are no continuous horizontal sections. There's only continuous vertical sections. Hope that does not make this structurally weak. I don't think it will. I think it should be okay. And I think there should be enough airflow. This will be the most fun part of the cut, because this bottom cut is in the best section to see what's going on. The other two cuts I think will not be as visible on camera. I just have the OBSBot sitting on top of the laser cutter. I don't have a tripod and stuff set up. While it's printing, yes. Left, right, top panel. So this is the left, right, and the top panel in one file. View is pretty bandwidth intensive. I guess there must be a bunch of image noise. Compared to this view, this view is much less bandwidth intensive. Yes, because I am streaming with QP-based VBR. The VBR constrains the bandwidth, but the bandwidth will still fluctuate to achieve a QP target. Because I'm streaming at 4K. So I'm streaming at 4K at a much higher bandwidth bitrate than Twitch officially sanctions as an ordinary plebe. Because like Iron Mouse and Nyanners, they all stream at 8,000, 8,500, or 8 to 8.5 megabits. One might say, oh, but they're special because they have partnered and blah blah blah. But no, apparently it's the bandwidth limits are not specific to your status, which makes sense because you couldn't do an ID lookup from the type of device that you would need to govern bandwidth. Cut, yeah, so it's doing this cut now, working its way up. So I guess maybe because of the position of the camera, it's this section just to the left of the current cut that you can't really see. Maybe you will be able to see most of this and the final cut. I do hope I didn't introduce some critical design flaw. I'm gonna get some food soon. 8 minutes. Yes, given this is in the other room, I am also using OBS, the OBS view, to monitor what is going on. Make sure that there isn't a fire that I'm going to have to then grab my fire extinguisher and dive in. Because you still can't hear the background noise. Okay, so what am I gonna do? So actually the DA2 connector, as is, will not fit. So I cannot do any test with the Alright, so let me position this here, right? I cannot do a test with the left panel in, because even though I have that slot cut out for for clearance in cable runs, that slot is not big enough for me to insert the DA2 power cable, because the DA2 the pins where the DA2 cable goes in are right where the captive nut assembly is. So there's no way to clear that. So I cannot test cannot test that. Only test the top and the right. And then I can leave this like the fake back in. Like the back here won't fit. Doesn't fit the design because this is the scrap front. But I can leave it there. I can leave it there just to test the fit of the other walls. So I should be able to put everything together, except the top will not be attached to the back, but the rest of them should work. And then I can close up the left side if it's not powered. So I can do a fit test of the left side without power, but I cannot actually power this thing on with the left side on. I'm pretty happy that the modeling of the standoff, though, for the NVMe Thunderbolt connector worked, that nothing went wrong here. I was a little worried that just having to eyeball measure this might lead to these holes not lining up. Happened to me before, but it seems okay. Where are we in the cut? All right, down to the last piece. Supposedly 1 minute and 41 seconds left. Oh, because it's doing the final profile of that top piece. Yeah, okay. If this all fits, in theory, the only remaining piece that I need to do any work on is the back, because the back needs a cutout for the extension, for the DA2's extension cable. This is probably the best. It's the least straining. I think that'll be fine. Oh, it's done. All right, cooling down. Keep the lid closed for a moment, yes, because there'll be plenty of fumes. Okay, let's go grab it and then bring these pieces back. Get rid of that stock. Don't need that anymore. Side. Let me get rid of this. Okay. Get rid of one piece weighted. Piece weighted. I don't think the stiffness is compromised. I mean, it is a little bit less stiff, I think, than the piece on this side. Not necessarily by a lot. Okay. Rid of this pile of scrap. I think that's not the way. Number one screwdriver. Now let's no, I can test all of them. That's fine. Let me I'll remove these all. Okay. Remove these all. Come on. Easy to get around these round holes. It's the sharp edges on the captive nut assemblies that are hard to get around. Not much I can do about that. They need to be shaped the way they are. Side. That's mildly annoying. Missed a few. All right, this panel that has no captive nut slots, much easier to take off because all of these curves are easy to wind around. Actually, it's directional. You pull this way. And there we go, done. So shiny. Okay, so what did I get on this? Something greasy and lubey. All right. Microfiber cloth will make quick use of that. All right, so this guy is for later. This is the top. Yeah, the slot is in the right place. And it's gigantic. That's okay. And then this side here. The top will go in last, second to last. So let's stuff out of the way. Let's see. A little bit too tight. I'm going to loosen up those bottom screws a little. Where is the... This way. Slot this way. Okay. So let's put a few of these guys in. Okay. This. Side here. do 3 down the front. Okay. Do the bottom. A little bit tricky. I don't really want it to drop. What's going on here? There we go. Not sure why that was so tight. Drop in. Rather, I don't want it to drop through. Well, I believe that I align these such that with the curve settings, it should be fairly. That's not right. Let me do this side. What's going on here?
Comrade, Community Showcase, has invaded the chat.
So let me do this corner here since that keeps sagging. Ah, all right, that fell through. Oh, it came out. Pushing a little bit too hard. Oh. More at the bottom, one more top. Going on. That's kind of snug. And then here we go. This one. Okay, good. And then we put the top in. One, two, three, four, five. What are you doing? See if I can do these in mass. Let me put the slot these nuts in. Okay, nuts are slotted in. Okay. About right. Snug them in. Okay. Not super rigid because this side is open. Just for a fit test. Sorry, the camera. This way. Just test for fit. Tight. Yep. Loosen those guys up a little. I should not have put the top in. Oops. Okay, so where are the trouble spots? All right, it will fit. Yeah, so I had some concern about the side here. And yes, it's a little dicey, but I think it'll work. Because I have some maneuverability with these holes. I think what I want to do is get one screw in on each side before doing the rest. I'll do them in the trouble corners. Here. One on the bottom here, directly opposite. And then I'll want one here on the side. I'm gonna have to take this off. I'm not sure that I want to do them all. I just want to verify, I guess. I think I'll do these corners here, and then I'll check this end, which is the part that I thought might be tricky. Ah, that's misaligned. Oh. Because these guys are not under a lot of tension, and so did not hold. It did not hold its shape. This corner needs to be a bit tighter. Then I'll loosen it if I need to. Okay, so this wall, partly because it's the last wall, partly because it's the one that has this troublesome, where it's hitting where I'm running into the NVMe adapter. Yes, the problem is not the cable tie. It's the protruding edge of the NVMe adapter here, which I can either... I don't have to do anything about it, I don't think. Just try to tension it the best I can. And that will be okay. Yeah, I think this will be okay. So this panel's okay where it is. Let me tighten down the ones that I know are set. Mainly front right and top. It's gonna have to come off. And front right and top are fine. Left side is in good enough shape that I can take it out. Same as the back. This should work. And it's pretty compact. Pretty compact, and it's pretty light. Yeah. Okay, so let me take the right side panel off. Didn't snip the tail off that. Active nut. Everyone else should be fine. This works. And access to the USB-C, no problem here. Plenty of clearance. Way more than I actually need. Just the right in the back panel. Right panel is ready to go, but I don't have the, I require some stuff. And then yeah, so then let's imagine it, let's put it this way for now. Got the USB-C up here. Okay, so there's not a huge amount of point because I have to take the top panel off also when that thing gets here. Because I need the top panel off in order to access the PCIe connector up here. That I think will get here tomorrow, probably tomorrow evening. So this is good. This is good. All right, all set then. That's it for today. I don't think I should have to remake any more parts, assuming that all of the bits that I get fit the way I tested and that we have enough clearance for the cabling. So that's it. Thanks for watching. That was a marathon today.